So firstly, we can just Google Python online, and we can randomly choose one. Like this is good. So, so firstly, I'm gonna introduce something called a variable. Oh. So this is called a variable. So we usually initialize it as a equals 0, and we can print a. Okay, so this is a variable a, and its value is now 0, and we print its value out. Okay, we click on the run, and we see the result is 0. And so do you ever learn some coding stuff or Python before?
A little.
Okay, so we can change. So it's called a variable because we can change the value of it, and we can like a equal a plus 1, and now it's 1. You can see this, and so this may be confused because this does not exist in math. And you can imagine in every coding stuff, you can imagine the equal notation as this thing. So you can just imagine it as this. You cannot write this, okay? So we calculate the right-hand side, it's a plus 1, and we give it to the left-hand side. So the a is 0 in the first place, and we plus 1, and we give it to a, and a is now 1. Okay, so that's what equal stuff mean. Okay, and this is also the same as a this thing. Okay, these two are the same. So now a is 2. Right. Okay, is everything clear?
Yeah.
Okay, and the next thing is we want to print some text. Okay, so this is a variable, and we want to print some text this time. And when you see this is called quotation, right? So when you see quotation, it's a text, okay? And it's often the first program that everybody write is print hello world, okay? And then we can see here, hello world is a text. And this is a variable, okay? And let me think. And we can, there's a third thing. So we can, oh, by the way, you must use English, and we often make mistake because we use Chinese notation. This does not work in code. Okay, we can only use maybe, but if we use the Chinese bracket, okay, then it's arrow. So we must use English stuff. And the third one is you put an F here and a quotation here, and we got some text, and here is the variable, and the other place are text. So you put an F here. So you got text too. So the text is, this is the text, okay? And inside the bracket is the variable a, and a is 2, right? So this is very easy. So we move on to list, okay? List is just a list of number, okay? It's initialized as empty, so like this. And we print list 1. then it's empty. Okay, so a list is just a list of numbers. It's just multiple numbers. Okay, we can use list1 dot append 1, and we print it again. And here it becomes 1 inside it. And we then append 2. So it becomes 1 and 2. Okay, one more. It becomes 1, 2, 3. Okay, this is a list. A list is just some numbers. Okay. And we often use append to add some number into it. And there is some index of the list. Okay, so we can print list1 0. So in almost every computer science stuff, the index begins from 0 instead of 1. Okay, so here we print list1 0, and that's the first element of the list. So it's 1 actually. And we see 1 here, right? And similarly, so to make things clear, and we use the F stuff here, and we say, right, so so inside the bracket is the variable, is the first element of the list, okay? And outside it is just text, so we print it. It's just list1 0, and these are text, okay? And the last one is the variable. So we often use like the F string like this, okay? And the same is the 1. So index 1 is the second, and index 2 is the third element. And we run this, and we got 1, 2, 3, okay? And if we say 3, gonna be an error, okay? Because there are only 3 elements here and no more. So similarly, is also negative index, okay? So -1, -1 is the last one, okay? So it's 3. And -2 is 2 here, and -3 is 1 here, okay? So that's this picture. So the index is 0, 1, 2, and -1, -2, -3. So is everything clear now? Hello? Your mic is off. Okay. Let's move on. Okay.
Yeah.
So the next slide is about some basic math. Okay. So in math, you multiply, and in Python is this stuff. I don't know what its name. Okay. So we print 2 multiply 3. Okay. Then it's 6 here, and then we print this stuff. This stuff is equal to like 2 to the 3. Okay. So it's 8. It's 8 here. And the divide is a little complicated, and 5 divided by 3 is like 1.6666, and so this one is like directly get the result of 1.666, and another stuff is 5 divided by 3 equals 1, and the remainder is 2. Okay, so the double slide maybe. So we got it's called quotation. I do not know. Okay, it's 1. And so this this stuff got the remainder, okay? So we can try it. 5, 3. Okay, so the first one is like 1.6, and second one is 1, and third one is 2. Okay, clear?
Yeah.
Okay, so the next line is if and for, okay? So we see A equals 6. I first give out the skeleton, okay? If A less or equal 6. No, I should say this. I first give out the skeleton, okay? Um, something else if and duplicated else something. This is the main skeleton, okay? So you should notice this stuff, you cannot omit it, okay? And mm, and here are 1, 2, 3, 4, 4 space or 1 tab, okay? So that means if we satisfy this, then we run this. Okay, and if this not satisfy, and we check whether this satisfy, and if this satisfy, then we run this. Okay, similarly, and if they all do not satisfy, and we run the final stuff. Okay, so that's the skeleton, and we can comment it. And by the way, this is comment. This is the the shortcut. It's really useful. And when you turn it into comment, and it just not do not work anymore in the code. Okay. So if I do not comment it, I got an error. Okay. Huh? I do not got. Okay. I do not know. Okay. So we commented. So what's comment is you got a mimi before, right? So we comment a cat, and it's a cat in the code. Okay. So then we try this out. So we say A equal 6. And if A, and by the way, you can only use part of them. So you can delete it, okay? You can also delete this. So you can only use 3 branch, okay? And you can use only 2 branch. And you can use only 1 branch. They are all okay. So say if A less than equal 6, 5, then we print A less or equal 5. And if A, else if A equal 6, we print A equals 6. So here's something very important, because if you use equal in if, you must use second it like 2 times, okay? Yeah, you just remember this. So similarly, we just use 3, and else we can print A is
Yeah.
greater than 6, okay? So we run this, and we got A equals 6, okay? And if we set A to 7, and we got A greater than 6, we say 4, and it's this, okay? So is everything clear for if? So we go into for loop here. We usually write for I in range 5. And similar for that, a tab or for space. Okay. And so this means we run this code for 5 times. Okay. And we say a equals 0, and we hear a plus 1. And finally we print a. Okay. So it's plus 1 for 5 times. So finally it's 5, right? And so as I said before, so everything in computer science is begin with 0. Okay. So here the I is, can see, we can see that. And actually the I is from 0 to 4. Okay. So the I goes from 0, 1, 2, 3, 4. Okay. And if we wanted to like start from 1, we can say range 1, 6, and we print I. So it goes from 1 to 5. Okay. So this is actually this stuff. If you see like A, B in Python, so it include A but does not include B. Okay, so here, here 1, 6. Okay, and it's actually 1, 2, 3, 4, 5. So it include 1, but does not include 6. Okay, so for example, we got A equals 0 and A I plus I, and then we print A finally. So it's 1 plus 2 plus 3 plus 4 plus 5. So we got 15, right? So is everything clear with for and if?
Yeah.
Okay, cool. Let's move on to the function. Okay. So let me first introduce this to you. So you see here .py is the Python file. Okay. And there's another stuff. And you see the Python file, you can just write code here and get all the output here. So it's very original, right? So actually you got some more elegant stuff. And here we can use it in Google. Okay. And lecture 1, and we can get one here. So this is called IPYNB. Okay. IPYNB. So this is almost the same as Py file, but it's more powerful. Okay. And it's more beautiful and convenient. So firstly, we name it as one. Oh, the time is limited. So it's named as LEC1 code. Okay, so we can actually just Ctrl C, Ctrl V, all the stuff here. Okay, they are the same. And we can run it. So it may take some time to connect it. And we got output here, okay? They are almost the same. They are just the same. And but it's more elegant because I can just start another code here, okay? And I can also start some text. I can explain something, okay? I can put it up, right? So here we see the function, okay? Let me think. So I got a equal 97. Okay, I want to check whether it's a prime number. You know what's prime number, right?
Mm-hmm.
So how to check whether a number is a prime? So we just for I in range, it start from 2 and end at a plus 1. Okay, so this actually goes from 2 to here 97. Oh, so A is okay. So 96, okay. So if any of them is can be divided by A, then it's not a prime number. So otherwise it's a prime number, okay. So we say if A divided by I and the remainder is 0, okay. And we return and we print, yes, we print not prime, right? And otherwise, so else we print prime. Does this work? Oh, yeah, this is a common mistake. You must use 2 equal here, right? Oh, I think I got something wrong. So let me see. This is a wrong code, sorry. Let's use a flag here, okay? So flag is 0, and if this the flag 1, okay, else flag, we do not need else anymore. So the flag is 0 means that it's not prime, and if flag equal 1, then it's prime. So run this, and if flag means this may be right. So 97 is not prime. Really? Oh, I got it wrong. So as long as there is 1, can be divided by that, so it's not prime, right? Sorry for that. Okay, so A equal 4 is not prime, right? So 2 is prime, 3 is prime, 11 is prime. Okay, is this code clear?
Yeah.
Okay, cool. But we only have 5 minutes left because Zoom seemed to, oh shit, Zoom seemed to limit the time. And so if I got another number, okay, B equals 30. We want to check it as. So for B, right? So 30, Really? Oh, what's wrong? Oh, I have to say flag 2, right? So A equals 11, B equals 40, right? So if you want to check multiple number, whether they are prime or not, you have to write the same code for a lot of time. So we can actually solve this by using function, okay? So we can avoid duplicate like multiple the same code, right? So and def, so the skeleton is here. Mhm. The skeleton is like this, okay? So we got def and the function name, okay? And here is the input value. And we run something and we return the output value, okay? And if we want to use it, then output value is equal to the function name and input value. So these are the syntax, okay? Okay, so this is the skeleton for a function, okay? And we name it as, so the function name we set it as is prime, okay? And the input value, so you see here and here, what's the input value is this, okay? So we can just name it as input, okay? And we just say by. So we first set the, let me think. Mm, okay, so get it here. So here is the function, okay? So here's the function. It's almost the same as that stuff. And we get input and we like traversal from 2 to the input. And if there is 1 that we can divide it and we return not prime. And if all this stuff do not, so if all this stuff do not succeed and finally we return prime, okay? So we can use this now and we can just directly print, or maybe the result equal is prime 5, okay? We done go to print it. The result is prime, okay? So we change it to 40. It's not prime, right? Yeah, so in this way we can like we can do it really elegantly and just we can also like directly print is prime like 6. Okay. Mhm. Y is 6 prime. Okay. Oh, what the fuck is it? So yeah, 6 is not prime. So we can also directly set print is prime 7 and is prime. Okay. So this is the function. So you see, we should write this stuff multiple times for every input number, right? So, and we can just like set this as a function, okay? And we can like very quickly get a result, okay? And the code is like shorter, okay? So is everything clear?
Yeah.
Okay, cool. And so the last stuff is this, okay? So actually, people has written a lot of function, okay? And we can just directly use them. We do not have to write them ourselves, okay? So we can import random. So random is a lot of functions that others have written and we can directly use them, okay? So let's get some code from here. Int. And this is, so remember this is from 1 to 5, okay? Include 1, not include 6, okay? So we can print it. So the int here means integer, okay? Integer is just, so this is just pick a random number from 1, 2, 3, 4, 5, this 5. Mhm. Why I got 6? Oh, really? Okay, maybe here it just includes 6, okay? I do not know. So this is a function, okay? So the rand int is a function, so we randomly pick one number from 1 to 6, okay? And there's another way to write this. They're the same, and we from random import random the same random. Okay, so they are the same. So import or from something, import something. So if you import random, so you got some random dot random. So there are a lot of functions, right, inside this. And you can also just import the one function here and we can use it to generate a random number. So is this clear?
Yeah.
Okay, cool. So I almost finished all the basic stuff. So they are actually very enough for you to solve a lot of problems. Okay. So we can actually use them to solve the birthday paradox problem. That's really interesting. Okay. So the birthday paradox. So the birthday problem is that in your class there are n people, and as long as there are 2 people have the same birthday, then we win. Okay. And otherwise we lose. So that's the definition. Mm, and we want to write code to simulate it. And actually, it's very difficult directly simulate the problem because you have to like maybe you have to get a list, add another code. We can also add some text that we are going to birthday problem now. Okay, right. Mm, so maybe we should like have a list. Okay, we have like list one equals to all the dates. Like that's really difficult, right? Let's give it up. Okay. So actually, this problem is the same as we randomly choose 1 to 365. Okay, and for n times, and we get to the same. So so this sentence is really more convenient to write code on. Okay, and we can use the function we just used. So the problem is clear.
Yeah.
Okay, cool. So we randomly choose one number from 1 to 365 for n times, and we get 2 for the same. This is too difficult. We set n to some specific number, okay? So how many students in your class? Like 30, 40. So this stuff is actually the number of students, okay? So we just like random. So we pick it for 30 times, okay? So for I in range 30. And we use this. 365. Okay. Then so in this code, we pick 30 random numbers, right? And we want to see whether it has collision. And so how should we see that? It's the code here. Yes. Okay, so I want to introduce something called a set. Okay, so the set and the list, the difference between them is that the list can have like duplicate number, okay, repetitive number, and the set cannot have repetitive number. So you can run this and everything's clear. So the list one is 1, 2, 2, 3, 3, 4, and the set is we use set to it, okay? We, this is a function, right? So then the list one becomes a set, and we give it to set one, okay? So the set one is actually 1, 2, 3, 4. So and this is also a function, so it calculates the length of the list or the set. So the list length is 6 and the set length is 4. Okay. So is this clear?
Yeah.
Okay. So we can use this to like check whether there are duplicate number in here. And we should make a list, okay? We can call it just first list maybe. And the first list is initialized as empty, and every time we got a random number and we append it to that. Maybe beautiful. Okay, and we first list dot append random number. Okay. So in this way, we finally got the birthday list, and inside the birthday list, it's 30 random numbers, right? So we can check this. So if the length of birthday list is equal to the length of the set birthday list, okay? Then we return, not return. Then we print. Yes, there are two people have the same birthday, right? And else we print no. Okay, so we try this. Oh, it seems like, I don't know. Let me see, it's right or not. Yeah, it's right. So here we simulate a class with 30 students, right? So this is the first level, okay? So, oh, by the way, there is something called the law of large numbers. So when you talk about probability, that means you do a lot of experiments and like see finally the result. Like if you toss a coin for 10,000 times and you get 5,000 heads, you get almost 5,000 heads. So when your experiment, so when the how to say when the number of experiment goes to very very large, and finally you can get like an estimate of the probability, right? So so we now just run one times, okay? So maybe we calculate write it here. So is this clear? So for 30 times, it's just a class with 30 students, and it's a random class, okay? And then we run this whole experiment for like 10,000 times, okay? First put it with two tab, and for J range, okay? And we want to mm, like set a count, okay? So you say yes count go 0, okay? No count go 0. So here are actually 10,000 like experiments, okay? And we want to, so if one experiment got two the same, then we just count +1, okay? And otherwise the no count +1. And we can finally print out and no count and this count divided by mm, mm, mm. Okay, can you understand the code?
Yeah.
Cool. So so you see oh, I'm sorry. Maybe there are some mistakes. So actually the length, if the length is equal, mm, this should be no, right? So the length is equal means there are no duplicate stuff in the list, okay? And Otherwise, it's yes. Okay, I made another mistake. Okay, so we okay. This must be right. And like if there are 30 students, so what's this is saying that if there are 30 students in one class, then with 70%, okay, 70% probability that there are two people have the same birthday. Okay. Maybe this is not clear. Maybe and delete two zero and add one person. Okay. 70%. Okay. So actually there are 10,000 experiments. This is a very large number, but your computer can just run all of them in 3 seconds. 3 seconds. Okay. So the computer is really fast. Mhm. So we move on. Okay, that's the second level. So we go to the third level. Okay, then we will change the numbers of students. Okay, duplicate the code. Okay, so now we will traversal all the value of n. Okay, so if we have a class of one student, two students, three students, and all the way to like 100 students, and we should test whether the so how the probability like change. Okay, so we firstly get them two tabs. Okay, and we for k in range mm, for n. Okay, for n in range because we are changing n here. For n in range from 1 to 1, so 101. Okay, remember that this is 1, 2, 3, all the way to 100. Okay, and mm, so we just need the probability, right? We just need this. So we delete the no count anyway. And we have a final probability list. Okay, it's initialized as empty. And so after running, so this should be changed to n, right? So after running 10,000 experiments for a specific n, and we got a probability for n, right? And we finally get the prob list dot append uh, and this stuff. Okay. And that's it. Okay, so we can maybe print it out first. And because it's a lot of calculation, right? So it's like 10,000 multiply 100 calculation. So we can like put it smaller, okay? Less experiments, so the faster running time. So is the code clear? So the third levels. Hello?
Yeah.
Okay, run it. This may take some time because it's a lot of calculation, right? And actually, we will finally plot it out, okay? So let me show you code. So here we import some function called plot. So it's used to plot something, okay? So the horizontal axis is the a list from 1 to 100, okay? And so this means like the student number goes from 1 to 100. That's the n here, right? And like the vertical axis is the prob list, okay? So that's the probability for every number n, okay? So we got prob list here. So this is the x-axis and this is the y-axis, okay? And it has a title. Mm, title is this stuff, okay? The one on here is the title, and we also get the x label. It's the label of the x-axis, okay? It's the number of people, and the y label, right? It's probability, okay? So it's here, and the green true is like the grid here, okay? I don't know how to pronounce this. Okay, and finally we can show it, okay? And we got the plot. That seemed to be right. Maybe you can see the birthday problem on Wikipedia. Oh, why it's Chinese? So we got a plot here, right? They're just the same, okay? So we finally plot the right one. Okay, so that's this. So do you understand this?
Yeah.
Okay, so let's move on to the final slide, maybe. So the birthday paradox means that only 23 people is enough for you to get a 50%, like there are two people who have the same birthday, right? So this is very counterintuitive in the first place, at least for the people who learn this for the first time, okay? And finally, you got some theory analysis. So we use some probability theory to finally calculate the result out, okay? Mm, so you must have learned combination and permutation in high school, right? And can you understand this? Like
Yeah.
maybe, oh, really? Okay. So this is just like the probability of mm, like no two people have the same birthday, right? So I got 23 people from 365 and uh, each take one date and oh, this is the date, okay. I guess 23 date from 365 and after each one, like it has less than mm, okay, maybe I should write it out. So you can understand this. So maybe I just do not explain this, or I have to write it out. Okay, so this is you got 23 date from 365. And you got 23 dates. There are 23. And you can choose 23 dates and you can choose 22. You can choose 21 and the finally can only choose the last date. Okay. So this is factorial. And this is the like the whole number of 23 birthdays. Okay. And you got one minus. So is this clear?
Yeah.
Okay, cool. So this is today's lecture. Maybe we stop the recording first.